solving systems of linear inequalities. Okay, the system of linear inequalities is just two or more inequalities. The solution, of course, is any point that works for all the inequalities involved, because there can be more than two. And we graph them because that shows all of the solutions that are possible. Now, when you're graphing, if you cannot graph a line, which some of you are still making silly mistakes on, then this is going to be tough. So you need to make sure you're good at graphing lines. Okay, we have to start with our boundaries. Here is a system. Y is greater than negative 2x minus 5, and y is less than or equal to x plus 3. This is a system of inequalities. The boundary lines are going to be y equals negative 2x minus 5 and y equals x plus 3. Okay. So we graph each boundary line. This one will be dotted because it's just a greater than. This one will be solid because it's got the or equals to included. We start with, these are in slope-intercept form. If you don't know the different forms, that's going to make things challenging. But slope-intercept form, that means you plot the y-intercept. The y-intercept is negative 5. And use the slope, negative 2, to get the next point. Now you can go down 2 and over 1 in the positive direction, or you can go up 2 and over 1 in the negative direction. And then you draw the line. Then you have to decide what side to shade, so you pick a point, and I always say 0, 0 if it's not on the line. Plug it in. 0, is it greater than, well, negative 2 times 0 is 0 minus 5. Is 0 greater than negative 5? Yes, it is. So this is the side of the line that we shade. Then the next one, graphing the line, the y-intercept is 3, so we put a point at 3. The slope is 1, up 1, over 1. Both of those are positive. Or you can go down 1 and back 1, where both of them are negative. Okay? Then draw the line. This one is solid, so we draw a solid line. Hopefully yours will be straighter than that. Then you pick a point. 0, 0 is not on the line. We like 0, 0. 0 is less than or equal to 0 plus 3. Well, is that true? Is 0 less than or equal to 3? Yes, it is. So we shade this side of the line. The solution set is where it's double shaded. Okay? So where both of them work, that's where all of the points within here will work for both inequalities. Okay. Let's look at some with some different forms. Okay? The lines are, here's 4x plus 2y is greater than or equal to 8, and y is less than negative 2x minus 3. This is in standard form, so our boundary line is 4x plus 2y equals 8. Okay? In standard form, now you don't necessarily have to make this little table, but I think it's easier. We're going to solve it, or we're going to graph it by plotting the x and y intercepts. The y-intercept is when x is 0, so 2y equals 8. Divide by 2, y is 4. The x-intercept is when y equals 0, so 4x equals 8, x equals 2. Plot those 2 points and see where we go. 0, 4, and 2, 0. It's a greater than or equal to, so it's a solid line. Oops. Hopefully yours will go through the points. Pick a point, see if it's true. 0, 0 is not on the line. When I plug in 0 for x and y, I get 0 is greater than or equal to 8. Is that true? Not true. We shade the other side of the line. Next equation. This one's in slope-intercept form. y equals negative 2x minus 3. Plot the y-intercept, negative 3. Use your slope down 2 over 1, up 2, back 1. It is just a less than, so it's dashed. Okay. And then plug in 0, 0, see what we get. 0 is less than 0 minus 3. Well, 0 is less than negative 3. That's not true either, so we shade this side. Did we shade anywhere twice? No, we did not. So therefore, there's no solution. You can have no solution with these types of situations as well. Okay, here is one where we've got an absolute value, okay, as one of our boundaries. Okay, first of all, starting with the first equation, y equals 5. That's a horizontal line where y equals 5. And it's going to be dashed because it's just a less than. And where is y less than 5? Everything below the line. Okay. Then the next one is y equals the absolute value of x minus 1. Okay, remember, there's nothing being added, and this one is a horizontal change. Anything happening inside the absolute value is a horizontal change, and it's either going to shift it left or right. It could flip it over the y-axis, or it could stretch it or shrink it. So this one is only a shift, and this is negative, so as Mrs. Sardella said, this is the bad twin. It's going to do everything. It's going to do the opposite of everything you expect, so it's going to move it in the positive direction. So the vertex is going to be at the point 1, 0. Then there's nothing here, so it's going to look just like the parent function, which is the v, which is up 1 over 1 in both directions, both ways. Okay, and it is solid. Plug in a point to see what works. 0, 0 is not on the line, so we can use that one. 0 greater than or equal to the absolute value of negative 1. Is 0 greater than or equal to 1? It is not. So we're going to shade inside the V. And where it's double shaded is right inside that little triangle. That is your solution. Here is a problem with 3 equations. We could graph it the same way. The solution will be the region that is shaded 3 times. Okay, so we've got the line y equals x. That's our first boundary. That is the line that goes through the origin with a slope of 1, and it should be solid, and I'm drawing it dashed. Shame on me. Okay. Now we pick a point and we figure out where y is greater than or equal to x. Okay, I'm going to pick, we can't pick 1, 1. How about we pick negative 2, 0. Test it. Well, let's see. Is 0 greater than or equal to negative 2? True. So we shade up here. Now we have x plus 3y is less than 5. So x plus 3y is less than 5. Using your x and y intercepts, when x is 0, y is 5/3. Okay, we just estimate that one. It's okay to estimate with this. When y is 0, x is 5. Okay. So 5/3 is 1 2/3, so it's going to be roughly here. 5, 0. It's just a less than, so it's going to be a dotted line. And test point, 0, 0. Is 0 plus 0 less than 5? Yes, it is, because 0 is less than 5. Check. So we shade this side. Now, one more line. I will use green this time. We have 2x plus y is greater than or is equal to -3. That is our boundary line. Okay. It's in standard form, so using the x and y intercepts is usually the easier one. When x is 0, y is -3. When y is 0, x is -3/2. Okay, and you just estimate -3 and -3/2 is -1.5. It is an or equals to, so it is solid. Now, where do we shade? Plug in 0, 0. Okay, 0 plus 0 is greater than or equal to -3. Is that true? Yes, it is. Check. So 0, 0 is over here. So that would be this side of this line. So our solution is this little triangle right in the middle.